So, Grace, when you read this, will you tell me one important thing that stood out to you about the 45, 45, 90 theorem? Good. Okay, so like I said, today we're going to focus on special right triangles. The first thing we're looking at is the 45, 45, 90, and then I just asked you guys to highlight or underline anything in your theorem that was important and figure out what the variables were. So it says both legs are congruent. Ryan, if you have two sides that are congruent, what kind of triangle is that? So you have two congruent legs. Yep. Okay, so if you have two congruent legs, which we have here, it'll be an isosceles triangle. Okay, we're going to come back to that because you do have a theorem for the isosceles triangle that you are going to be applying. All right, Julia, what's something else that's going to be important besides the both legs are congruent? Good. Okay, so the other thing we're going to focus on is the length of the hypotenuse is the length of a leg times the square root of 2. Now, both of these are represented in both the picture and in your equation. So if we look at our picture, we have this. It's a fancy looking L. If you have the fancy looking L, that is going to represent the length of a leg. Okay, so fancy looking L is going to be the length of a leg. Now you have two legs. Get it? You have two legs? Really? You do? You have two legs on a triangle and on your person. And if two of the sides are legs, what's the other side called? Hypotenuse. Right? Lance, how can you always tell where the hypotenuse is? It has a relationship with what? What's something you know about it? Well, let's look at our picture. Yeah, what is it, Tyler?
It's across from the right angle.
Yeah, it's always going to be across from the right angle. So if this is your right angle, hypotenuse is always directly across from it. So it really is going to be a lot about the angles today. You're going to see a lot of similarities with things we've already talked about. Remember how this past week we've been studying how when you have a smaller angle, it's across from what? The smaller side. So there are lots of things that should make sense here. First, isn't 90 degrees the biggest angle? The hypotenuse is going to be the longest side. If both of these angles are the same, which means not one of them is larger, the sides across from them are going to be equal. The angles are the same, the sides across from them are the same. And that is your isosceles triangle theorem that we learned about last chapter. So for this, it tells you AB is equal to, we have this L root 2. What this is telling you is that the hypotenuse, which I like to abbreviate as H is going to be equal to the length of your leg times the square root of 2. So this is going to be your special rule. So if it's a 45, 45, 90 triangle, you are going to use the fact that the hypotenuse equals the leg times root 2. Okay, so this is only for a 45, 45, 90. So if I say what's the rule for a 45, 45, 90 triangle, you would tell me the hypotenuse equals the length of a leg times root 2. And you just have that one equation for it. So when you are trying to find the side lengths, it tells you to find the value of x, but your answer has to be in simplest radical form, which is something that we've been working on. The first thing I want to do here is identify what my hypotenuse is, and what my leg is. Okay, so Lance, tell me how I know what the hypotenuse is now.
It's the biggest side.
Okay, and
It's across from the right angle.
yes, okay, so your hypotenuse is going to be the longest side. For this one, we have x and 8, so technically we wouldn't know which one is longer. So, but we can always use the right angle. So because x is across from the right angle, this is going to be our hypotenuse. In a 45, 45, 90, the other two have to be what? Well, your angles, but yeah. But your other two sides are going to be congruent, and they're both legs, right? So that means if this side is 8, what does this side have to be? 8. Now, it didn't ask us to find that side, but you might have one that does ask you, and the legs are going to be congruent. So when you are solving, you're going to use h equals the length of the leg times root 2. In this case, our hypotenuse is x, so I'm going to go ahead and substitute that in for h. My L, my leg is 8. And this is already solved. Okay, there's nothing to solve for here. X is already by itself. So if you're given the leg, you can find the hypotenuse very quickly. It's just the leg times the square root of 2. So 8 square root of 2. Okay, so if you're given the leg, that's good times. If you are given the hypotenuse, like we are in B, you're just going to have to do a little bit of solving. So let's go ahead and label. I found my right angle, which means I'm going to label this is my hypotenuse. Now, these are both x. If they're both unknown, but they're labeled with the same variable, we know that they're congruent. Now, we can use the isosceles triangle theorem that we learned in the last chapter. Okay? The theorem tells us if you have two legs that are the same, the angles across from them are the same. Because this is 90, what do these two have to add up to? They have to add up to 90, right? Because altogether they have to add up to 180. 180 minus 90 is 90. Cut 90 in half, that's when you get 45. So yes, this is a 45, 45, 90 triangle. Okay, so if it's a 45, 45, 90, then we can go ahead and we can use the fact that the hypotenuse equals the length of the leg times the square root of 2. So my hypotenuse is 5. My leg is x. Okay, so h is 5. My leg is x. I am going to substitute in x because the direction asked me to solve for x. But now that I'm looking at this, it should feel familiar to you. What does this look like? It looks like number 6 from your bell work, doesn't it? Okay, so Alex Lynch, what are we going to do to both sides to solve? Nope, so you only want to take the square root if you have x squared, and we don't have that. So you want to get x by itself. What do you want to move over? The root 2, right? Okay, so how do I do that? You don't want to do a square root of a square root. Really, that would just give me the square root of 5 equals the square root of x times the square root of 2. That's too much. You have to think about what operations in between these. So when you have x and root 2, what operations in between them? So the operation, if you can't see it, is what? It's the only one where you can't see it, right? What's Danny whispering to you or mouthing to you? Are you mouthing anything to him? Multiplication, right? Right? If you can't see it, it's multiplication. That's something that you know, right? So how do you undo multiplication? Yep. So what am I going to divide by? Close? Root 2. Yep. Okay, so if I divide both sides by the square root of 2, let's think about why we do that. We're trying to get x by itself. If I take the square root of x, that is messy because I don't have a power of 2. If I divide by the square root of 2, what happens here? What's root 2 divided by root 2? Yeah, they cancel out because they make 1. So root 2 divided by root 2 is 1. 5 over root 2, I'm going to keep it for right now. Okay, but this answer I have to do what with? What's the word? Cass just told us. Rationalize. Okay, so now we are going to rationalize the denominator. Okay, so Robert, what am I going to do to rationalize? Perfect. So a lot of times what people will say is multiply by the square root of 2. But Robert didn't say that. He said it right. You multiply by the square root of 2 over the square root of 2. Because the square root of 2 over itself is what? 1. Okay, so Ava M, help me multiply straight across. So if I do 5 times root 2, how do I write that? Not sure? Okay, so see how one's outside the radical and one's inside? Okay, so then that means you can't combine them. You just have to leave them as 5 root 2. So on the bottom, you have root 2 times root 2. They're both inside the radical. So if you multiplied root 2 by root 2, you know what that would be? I just can't hear you. That. So think of 2 times 2, which is what? Yep. And if you have the square root of 4, what's that going to be? 2. Yep. So this is the pattern that we talked about yesterday, right? Root 2 times root 2 will be... Are you guys with me or no?
Yeah, I forget.
Okay, so root 2 times root 2 will be 2. Okay, and you guys had one like that for bell work today, right? Was it root 3 that you had today? Root 3 times root 3 was 3. Yesterday on the board we did root 5 times root 5, and that was 5. Root 6 times root 6, and that was 6. And we did root 7 times root 7, and that was 7. Okay, so that's still going to hold true for this. Now, 5 divided by 2 is going to be a decimal, so I'm going to keep it like this. If you get a whole number, you can always reduce. All right, so that's for 45, 45, 90 triangles. If you have a 30, 60, 90, that is also a special right triangle. For 45, 45, 90, we only had one rule. For 30, 60, 90, we have 2 of them. So the first rule is that the length of the hypotenuse, whatever that may be, is going to be 2 times the length of the shorter leg. So the length of the hypotenuse is 2 times the length of the shorter leg. Now, when you look at this picture, they've already labeled some things for you. Based on what we have done this week, you know that the smallest side is across from the smallest angle. Out of 30, 60, and 90, what is the smallest angle? 30, which means the side across from it is going to be the smallest leg. So S is the short leg. Okay, so when they say AC is equal to S, what they're telling you is that S is the length of the short leg. Now, the short leg is always the best one to have because if you look at your 2 equations, these are both going to be related to the short leg. AB is your hypotenuse. Again, you can find your hypotenuse because it's across from the right angle. So AB is the hypotenuse. What we would say is the hypotenuse is 2 times the short leg. Okay, so this is saying that the hypotenuse equals 2 times the short leg. All right, so if the short leg was 5, what would the hypotenuse be? What would it be? 10. If the short leg was 4, what would the hypotenuse be? 8. So it's always double, right? You could also go backwards. What if you knew the hypotenuse? Let's say the hypotenuse was 10. What would the short leg be? 5. Let's say it was 20. 10. Okay, so you can go either way. Now, the other leg is going to be found by doing the short leg times root 3. So because this is the short leg, I call the other one the long leg. See how they called it BC? I call it LL, long leg. Okay, so LL means the long leg. Okay, so that's what I'm going to write here, is that the long leg is going to equal the short leg times the square root of 3. So S times root 3. Okay, so the long leg is equal to the short leg times root 3. So this is really similar to the one for the 45, 45, 90. And that's what we also have in our theorem that tells you that the length of the longer leg is the length of the shorter leg, but multiplied by root 3. All right, so now for our triangles, we are going to find the values of x and y. You are still going to be writing those in simplest radical form. So just like last time, the first thing that you should do is figure out which side of the triangle is the what?
Short leg.
Yep, I would do the, well,
Middle.
the longest is the hypotenuse. Okay, always start with the hypotenuse because you know the hypotenuse is across from the right angle. So our hypotenuse here is 22. Now to the side, I'm just going to write what each thing represents. So hypotenuse H is going to be 22. To find the short leg, I'm going to look at my angles. If this is 30, then this means this is the short leg. This is across from 60, which makes this the long leg. Okay, so it's all about those angles. All right, now the short leg we call S. So S is going to be X in this one. The long leg is Y. So LL is going to be Y in this one. So you are going to have to write them in terms of X and Y, which is why I assign those the variables. This one's a little bit different because you have two equations. You have to decide which one to start with. The way that you decide is based on what number you're given. Okay, so the only numeric value we're given here is 22. And 22 is the what? Hypotenuse. So since your H value is 22, we will use the equation H equals 2S first. Again, the reason why I'm using that first is because I have H. So when I look at my two equations, which one has H? H equals 2S, the first one, right? Okay, so that's why I'm using it. If I tried to do this one, all I would have are variables and I wouldn't be able to solve. Okay, so if you do that first and you can't solve, that's fine. Just go ahead and plug them into the other one. All right, so now I'm going to plug those in. So I have H is equal to 2S, but my H value is 22. And then I just have to solve this equation for S. Okay, so what am I going to do to both sides? Divide by 2. Now, really, when you're given this type of equation, oh, sorry, for S, what's our S here? Or X, so I'm going to put that in because you're solving for X. Okay, so your X equals 11. Now, this is one where you don't have to use your equation if you remember your pattern. We just talked about how your hypotenuse is twice as big as your short leg. So what times 2 is going to give you 22? 11. You can just ask what's half of 22? 11, right? See how you wouldn't necessarily have to do your equation for that? Okay, so you know that 22 divided by 2 would be 11. All right, now the second thing we have to do is use the other equation. Okay, so now we're going to use the other equation to solve for y. All right, so we found x, now we're going to solve for y. So I'm going to use the long leg equals the short leg times root 3. Well, keep in mind, I just found x. Okay, so my s value is equal to x, and that would be equal to 11. So when I go to plug these in, my long leg is y, my short leg is now 11 times the square root of 3. And look, it's already done. Y is by itself, so y is going to be 11 root 3. Okay, so short leg times root 3 will be the long leg. Short leg times 2 will be the hypotenuse. For B, we're going to start it the same way. Okay, so Andrew, what did I do first?
You figured out which one was the hypotenuse.
Good, okay, and which one is the hypotenuse here?
Y.
Perfect. Okay, so your h value is going to be y. After that, you're just going to find your other values. So, Dion, what's going to be my short leg here?
X.
Good. So I'm going to label my short leg as x, which means my long leg has to be 15. Okay, and again, that's all about your angles, right? So if this is 30, this is going to be your short leg. This is 60. Across from it, that's going to be your long leg. Now, when you're deciding what equation to use first, you just have to see what number you have. The only numeric value we have is for the long leg. So that means the first equation I have to use is the one with the long leg in it. So I'm going to use the long leg equals the short leg times the square root of 3. Notice that this is different from the one we used last time, just based on what you're given. Okay, so the long leg is 15. I can plug that in. The short leg is x. I can plug that in. And then look where we are. Where are we? What does this remind you of?
A warm-up.
Your warm-up, right? We're back to the bell work.
Yes.
So if you are solving for x, Alex Lynch, you're going to tell me how to do this.
You multiply it by the square root of 3.
Okay, it is multiplied by the square root of 3, so we have to,
No, I meant divide.
yes, good. Okay, so we have to divide by the square root of 3. Yes. So we can see those are multiplied together, which means we want to divide, because when we divide, we get 1, and then x is alone as we would like it to be. So now we have 15 over the square root of 3. We don't like that. Okay, Hannah, why don't we like that? What specifically is not a whole number? The root 3, right? So we want the denominator to be a whole number. We don't want it to be a radical, so we have to rationalize. Okay, so if x equals 15 over root 3, Allie, what am I going to do once I get here? Good. Multiply by the square root of 3, square root of 3. Good. Okay, again, you want to multiply by root 3 over itself, not just root 3. Good. Okay, so then, Cam, tell me what I get when I multiply.
15 square root 3 over 3.
Yes. Pretty good for being asleep. Okay, and then once you get here, can you simplify? Yes. You and Alex Drumel-Smith, can you tell me why I can simplify this?
Because, like, 3 goes into 15.
And they're both outside the radical. Yep, so 15 divided by 3 is 5, so I can leave this as 5 root 3. Okay, so that's going to be my x value. So now I have to find my, what else do I have to find besides x? Y. Okay, so if I used long leg equals short leg times root 3 for the first one, for the second one I have to use the hypotenuse equals 2 times the short leg. Now I can substitute. That's where this comes in helpful, right? I just found that x was 5 root 3, so I'm going to write that down, my little grid here. So now when I plug in, I have y equals 2 times, and then when I plug this in, I usually put parentheses to show I'm going to multiply, and now I'm going to multiply 2 times 5 root 3. Okay, Joe, can you tell me what that's going to simplify to?
10 root 3.
Good. Why can you multiply the 2 and the 5 here? Good. They're both outside, which is why you can multiply. If one's inside and one's outside, they can't play together. Okay? Now, I'm going to have you write down your homework. When you are done writing down your homework, you need to do the following. After your quiz, you can work on your homework. So if you have your textbook, or if you're going to borrow mine, you can have out a piece of paper and your notes. They just have to be either tucked into your book, notebook, or folder. If you have a book to read for when you're done and you'd rather do that and your homework at home, that's fine. You can put your book under your desk. You're not going to be going to your bag when you're done with your quiz. So whatever you're going to do afterwards, which is one of those 2 things I mentioned, or if you have homework for another class, I'll let you do that too. That needs to be underneath your desk. Okay, you will also need a pencil and a calculator. Okay, make sure everything else goes in your bag. Your bag is going by my desk.